Well, this is the STS-88 crew video, the first assembly flight of the International Space Station. And our flight really started back in November of '98 with the launching of Zarya, the first Russian-built module, paid for under contract to Boeing, launched aboard a Proton rocket from Baikonur in Kazakhstan, the Russian launch site. This is Zarya underneath the shroud here, and the 6 main engines of the Proton rocket lifting it up into orbit. We had everybody over to the house that evening to watch the launch, and we were all pretty excited when Zarya made it safely on orbit, because we knew we were going to have a mission a couple weeks later to take Unity up to Rendezvous with Zarya. And here's a great shot of the orbiter on the pad. I don't think there's anything that's more exciting than seeing a space shuttle fueled and ready to go at night with the xenons shining on it. We had a little bit of a delay the night before getting off the ground, but the next night we came back, we were pumped up and ready to go, and excited about getting out to the launch pad for what turned out to be an uneventful ascent. Endeavour is just a fantastic spaceship. Of course, the large orange external tank holds the fuel and oxidizer for the main engines. Here we see the vent cap retracting over the external tank, and a view of that from the cockpit too, out the commander's window. We've got our visors down now, and we're ready to go for launch. The main engines ignite 6 seconds prior to launch, a little better than 1/3 of a million pounds of thrust in each one. You can see them push the whole stack forward as it moves forward. When it comes back to the vertical, that's when the solid rocket motors light. A night launch is pretty spectacular. Here's what it looks like in the cockpit, shaking and vibrating and being pushed back in your seat, accelerating up. You really know you're going somewhere. The light from the solids and the main engines just turns nighttime into daylight, and all that light comes back in through the windows of the orbiter also. Here we are about 30 seconds into the mission. The solid rocket motors burn for about 2 minutes and get us through the thickest part of the Earth's atmosphere. Here you can see the thrust tailing off, and they'll separate away. And we'll get another view of that from inside when the separation motors fire and push the solids off. Pretty big flash there, really gets your attention. And then they separate back and are recovered and refurbished for use again, and we continue on to our orbital velocity, 17,500 miles an hour. Here's main engine cutoff. You can see a stopwatch floating by, and flashes out the window are the 800-pound reaction control jets firing to move us away from the tank and maintain our attitude. And a great shot of the external tank. You get a real sense of speed as we track the external tank over the Pyrenees here, going a little better than 5 miles a second over the ground.
Get onto orbit, and the first thing we have to do is to open up the payload bay doors so that we can start cooling all of the electronics inside the orbiter. The doors are actually opening at a faster speed here, shown at a faster speed than what we actually opened them at. It also gave us our first really nice view of Unity in the back of the payload bay.
On the second day of the flight, we went ahead and checked out the shuttle's robotic arm to make sure it was operating fully, and the shuttle's robotic arm worked just great. It flew identically to the way that our simulators fly. These are the snares closing. That's the manner in which we grappled Zarya, was through closing those snares onto the grapple fixture that was mounted to Zarya. And then on flight day 3, it was time to extract Unity from the payload bay. It was wedged in there pretty good. We had a fairly limited clearance to bring it out of the bay, so the whole operation took about an hour and a half to maneuver it up and then onto the orbiter docking system that you saw on the forward portion of the payload bay. And we just flew the arm very slowly. And Jim was great help being my assistant and letting me know how quickly we were moving the payload. We then pitched it up about 90 degrees, rotated it around to align it properly with the orbiter docking system. And the unique thing about mating these components is we actually didn't use the arm to bring it all the way down onto the orbiter docking system. We took it so it was 6 inches apart, and then we fired the thrusters on board the shuttle to provide the closure rate necessary to attain the capture sequence. And you saw the thrusters firing there.
Nancy did an outstanding job pulling the payload out of the payload bay Unity. Couldn't have done it better. Very smooth and controlled and precise. She had less than an inch of clearance on either side as she brought it up. She was pretty happy when everything turned out right. And here you see the final closure of the Zarya with the orbiter docking station, just like we dock with Mir Space Station. Once pulled together, we have a solid mating surface. We drive the hooks and can pressurize it so we can go inside.
We had a lot of EVA equipment that was stowed in the middeck of the orbiter, and every time we had spare time, we would go down and start to prepare that equipment for going outside on our 3 spacewalks.
The rendezvous was absolutely fantastic to see Zarya, which means sunrise in Russian, out on the horizon as we closed in on it for our capture. What a beautiful sight. Rendezvous is a real team effort. You can see us working on the flight deck here as we approach Zarya from 600 feet underneath it. Everybody's taking pictures. There's Jim using the handheld laser to get an accurate distance from it along with our other tools. Rick has moved up into the commander's seat, and I'm moving back to the aft flight deck to fly Endeavour as we come up to 600 feet and then move 350 feet out in front of Zarya and then come up 250 feet above it and fly it right down in the payload bay. We were using cameras for positioning. Here you can see it approaching its movement down in the payload bay, actually disappearing behind the node as it gets in closer. And here's a computer view of our profile as we flew it in.
We use the laptop computers to help us better understand orbital mechanics because it's not always intuitive.
The final grapple and proximity operations were done at night. You could see it starting to get darker there, but the orbiter payload bays and the cameras we have allow us to light it up so that we can see it well. We ended up bringing it down in the payload bay and then station keeping on it for what Nancy and I call the longest 17 minutes of our life, having Zarya about 2.5 to 3 feet from the end effector and keeping it still there.
This is a view from the end of the robotic arm and the camera located on it, and this view is now actually from the Russian module Zarya looking down on the arm as it comes into grapple. We actually didn't have that view in the cockpit, and so it was quite a unique experience to know that the ground was looking over our shoulder literally as we came in for the grapple. So we brought it down right over that grapple fixture, that long pin, and closed the snares that you saw in the earlier version to attain the grapple and rigidization process required to maneuver Zarya around. We were very, very happy after we had grappled this 45,000-pound free flyer after Bob had literally flown formation with it at Mach 25. And then it was time to install Zarya on top of Unity. Again, we were operating almost at the limit of the robotic arm because the Unity module extended about 40 feet out of the payload bay, and so the arm was almost fully extended as we brought Zarya up and over Unity into the install position. We actually couldn't see the mating surface where it was going to mate, so we had to use cameras alone. This is the elbow camera view. And again, we fired the thrusters to attain that capture sequence with the androgynous positioning mechanism.
Just a really nice view of the space station docked to Endeavour out the overhead window. Now it's time to go to work and start the spacewalks.
Here you see Rick and Sergei as they're opening up the hatch that goes from the middeck or living volume of the space shuttle back into a tunnel that leads to the airlock where our spacesuits were stowed and what we use to go in and out of the space shuttle on our 3 spacewalks. Here we are in the middeck, Jim on the right and myself on the left, as we're demonstrating in space that you can put both your legs into your pants at the same time in zero gravity. After I got my pants on, I went into the airlock to start getting into the rest of the suit, and here's Jim finishing his suit up. and going back through the tunnel to the airlock to get into the upper half of his spacesuit. You might notice there's a lot of tools and equipment stowed in that tunnel. There were more that were put in there after we got into our suits, and we used that volume very much to our advantage to transfer a lot of equipment outside to be added to the external surfaces of the station. Jim now into the upper half of his suit, he's putting on his Snoopy cap, his comm cap. We had to put on our gloves, button up our waist bearing, and put our helmets on, and then go through a check out of the suits and a pre-breathe to make sure that we didn't have any problems with the bends. And then when that was all completed, it was time to go outside and start our task.
Here's the cracking of the egg as Jerry opens up the thermal cover and begins the first spacewalk.
We went right to work. We had one crew member that was normally working on the end of the arm and a foot restraint that we had attached there. And the other crew member normally did most of his work in a free float manner, holding on to the sides of the orbiter and space station as he did his work. Nancy operated the mechanical arm for the first 2 spacewalks, and Bob operated on the third one. The arm gives us a very good work platform. It gives us opportunity to have our feet anchored in a foot restraint, and therefore leaves both of our hands free to do the types of assembly work that we were doing. The most important part of the first spacewalk was the connection of 40 different electrical connectors that allowed all the communications and control signals to be transferred between the various different elements of the station, and also, importantly, the electrical power to be transferred from Zarya down to the Unity module so that we could start to activate all the systems inside the US-built Unity module.
Here you can see the power tool that we used to loosen a lot of the bolts that were holding down the cables for launch.
Jim normally was responsible for removing those cables, both the bolts and clamps that held the cables in place, and then he would hand those off to me, and I would make most of the electrical connectors. He also made some of them. And you can see we're working at the orbiter end of the node there, finishing up the electrical connectors there. We then strung a slide wire, which was something that allowed us to transport ourselves up and down the side of the node very efficiently. Then we went to work at the top of the node to remove the cables at that end from their launch positions and to connect those for their on-orbit use. You can see Jim here translating up the side of the node using the slide wire that we had just installed, and you can see he's carrying a foot restraint with him that he used for some of the tasks up at the other end of the station.
This shows how useful the body restraint tether is. It's a way of carrying equipment around or of attaching myself to a handrail so that I can have a more stable area to work and can free up my hands to work if I need to.
Here I am again up at the top end of the node, finishing up the connections of the electrical connectors from the PMA, and here are Jim and I now up removing the cables from the Russian-built hardware, Zarya, and transferring them across to the PMA-1 U.S. hardware and allowing electrical power to flow into the U.S. half of the station. Since we were ahead of our timeline, we continued on with tasks that were planned for our next spacewalk. And here we are transferring some equipment so that we can each go or do our own task. We were installing some handrails and some additional foot restraint sockets that were used on subsequent spacewalks.
After the completion of the first spacewalk, we then activated the space station from inside and actually turned on the computers and electrical power to it, and what a great moment that was. After that, we boosted the space station to a higher altitude using the +X RCS jets on the orbiter. Each one of those jets gives about 800 pounds of thrust, and through a firing sequence that required a lot of analysis so we didn't break the space station. You can see it oscillating back and forth here after one of the firings. We boosted it approximately 8 nautical miles with 11 firings. A little oscillation in one of the solar arrays there. It was 2 minutes and 10 seconds between firings, and that all damped out before we did the next one.
Okay, on the second spacewalk, it was my turn to go outside first to get on the arm, and our primary task on that day was the early communication system. What we were doing is bringing up a communication system that would allow Houston to have video teleconferencing and command and data to the fledgling space station. Although the Russian side is prime for communications early on, They are restricted to communications during their ground passes, and that leaves a lot of the orbit with no communications to the station. And here we are transferring some of that equipment, those antennas, using the arm and the body restraint tether. You can see here that with an orbit that goes around the Earth every hour and a half, that there's 45 minutes a day, 45 minutes of dark. And during the dark times, we keep working using our helmet lights. Here we are up at the Zarya Unity interface, and from there I transferred with a boat hook. There are antennas that the Russians had expected to have deployed, but which did not employ, one on each side. So Jerry and I, each on 2 different spacewalks, took this boat hook and encouraged the antennas to deploy. It turns out they just needed a little nudge, and after doing that, and allowing a little bit of time, perhaps in this case, to warm up, and don't blink here, because what we'll have in a moment, it'll show you what the antenna itself looks like, and then we'll show a picture of the deployment itself. The antenna is a coiled metal on a spool, and there goes the spool. So with activating and deploying that antenna, now the Russian Toru system, which is a manual backup to their docking capability, would be fully operational.
Jim turned real quick there and said, "Where'd it go?"
I did blink and missed it, and I made a quick turn to try to see where it went. On the next one, which Jerry will tell you about on the last EVA, I didn't blink. This was a shot of the end of that final spacewalk as we were cleaning up the payload bay.
At this point of the flight, we had a space station that was ready to go inside, and we began our first day of docked operations with actual ingress into the space station. And what a highlight of the mission to see everybody's hard work come to fruition. Been a long time coming, but to go inside the space station for the first time was really exciting. Here we are opening the hatch, going from the orbiter docking station on into the pressurized mating adapter 2, kind of like the front porch of the space station here, and then opening the main hatch into Unity. And Zarya means sunrise in Russian, and of course Unity is binding us all together. It's the connecting piece which holds all the other modules from the space station. It was a very bright, roomy, and nice place to be. It was quite a sequence to go through all the checks that we had to before making sure it was safe that we could open the hatch, making sure the pressure was correct on both sides. After progressing on, we went through PMA-1 into the first compartment of the FGB of Zarya, and then opening the hatch into the main compartment of Zarya. The purpose of the FGB is to provide the initial electrical power and flight control for the early stages of the space station. Here we are all inside Zarya for the very first conference from the space station. Sergei Krikalev, our Russian crew member, will actually be going up to live on the space station with Bill Shepard and Yuri Gudzinko, and he's checking out his new home here, future home. Sergei has over a year's spaceflight experience on the Mir space station, and as you can see, he readily adapted to microgravity and being home on this module. Watch how effortlessly he translates down to the other end. Very nice place to be, more of a corridor than anything else, not meant for living. Here we are with the early communication system. Jim and Jerry installed the antennas on the outside, and then Jerry and I installed the boxes inside.
The Zarya had 6 batteries, one of which was not operating fully after the launch, which was 2 weeks prior to the launch of Endeavour, and so they had the opportunity to send over a replacement unit that Sergei and I removed and replaced, and an hour later it was up and functioning. So we felt very good about that, and it's another testament to having human beings in space to fix things and get things operating again. We also had to remove a lot of structural panels and bolts that were put in specifically so that the modules could withstand the loads at launch. And we wanted to remove those to make accessibility behind the panels easier. So we ended up bringing back about 800 bolts and nuts and washers back from the space station.
We had to pinch ourselves every time we looked out the overhead window. It was just hard to believe that we were docked to a new International Space Station. The view of the aft and forward flight decks of Endeavour, kind of take you on a little tour as we transit through the mid-deck access hatch. Behind that door and curtain is the bathroom on the space shuttle. The mid-deck is where we do all our living and sleeping and eating. Here you can see Jim down on the mid-deck. He was in charge of transferring all the equipment to and from the space station, making sure that what went that was supposed to got there and what didn't stayed. Rick's bringing back some stuff that had been removed from the space station for shipment home to Houston. These large bags held all that equipment. You can see it was kind of a tight squeeze. We had a lot of stuff packaged all over. Again, transiting through the hatch into the tunnel that connects to the airlock. You can see a booster fan down there to help circulate air between all the modules so that we could scrub the CO2 and provide oxygen for everybody, as well as maintaining the proper temperature and humidity. Instead of going out through the aft hatch, we now go up through the upper hatch of the airlock into the space station. More of that ducting circulating the air. Into the pressurized mating adapter, and then down into Unity. Here's Jerry and Nancy reviewing procedures for the next work that they have to get started on. We were really busy for the 2 days that we were docked to the space station. Across Unity into pressurized mating adapter 1, and here comes Sergei floating by as he exits Zarya. Into the first compartment of Zarya. Again, you can see the ducting that we installed. And finally into the main compartment. Again, Zarya is not meant to be a living module. It's a working module and more or less a corridor between the other modules of the space station. A really fantastic facility. Probably one of the sad points of the mission was when we closed the hatch on the space station after being aboard for 2 days. It was really, we wanted to stay longer. It was a great place to be.
Here we are checking out one of the simplified aid for EVA rescue, a little jet backpack before the third EVA.
One of the primary tasks of this spacewalk was to add a very large bag about 3 feet on a side to the outside of the station, which contains a lot of tools which will be used by future crews in the assembly processes of the station. After that was done, then Jim and I came back down to the orbiter end of the space station and disconnected 6 cables and stowed them. Those cables are no longer needed, and to get ahead for future assembly tasks, we removed those cables and stowed them.
It was very symbolic. It really represented the permanent joining of our 2 countries in this space endeavor.
Then the second of the 2 Toru antennas that had not deployed properly were attended to, and you can see me on the foot restraint here using the boat hook or pole to release that second antenna, and there it goes. The spool missing the tail of the orbiter by quite a few feet. We then proceeded all the way to the top of the Zarya stack, about 80 feet out of the payload bay of the orbiter. We installed a handrail up there at the top of Zarya, and then also identified 2 exposure trays that were no longer in their proper on-orbit configuration. They probably vibrated free during launch.
You have to look very carefully to see us up at the very top of that stack, 2 small figures working.
After we were given go from the ground to fix those 2 trays, we did that, and then we proceeded back down Zarya, back down onto the node. We finished off our operations on the stack of the station, and then had the opportunity to do a flight test of the rescue backpack, the little rocket backpack on the back of my suit. We identified a couple of problems that we're going to fix, and we'll have a fully functional, satisfactory way for a crew member to save themselves should they become detached from the structure of the station.
Sure was a pretty sight, seeing the space station attached to Endeavour, but then came the point in the mission where we had to separate and prepare to come home.
And this next sequence of shots again highlights all the teamwork on this crew that really went into almost every event. There were at least 2 of us, and you'll be able to see here as we separate right there from PMA-2 from the orbiter docking system and begin to back away. When we get to 2 feet, then I'll put in some out pulses which will cause Endeavour to fly away from the International Space Station.
Rick was at the flight controls at the aft flight deck for this portion of the mission and flew Endeavour away from the space station out to a distance of 450 feet and then flew around it 1.5 times, and he did an outstanding job.
We undocked in darkness, but very quickly the sun rose, and this shows everybody. There's Nancy at the front inputting the orbiter attitudes into the Space Shuttle computer system. There's Jerry is closing out the docking system, performing the final steps to secure that. And Jim was assisting with the computers and taking handheld laser marks. As the sun came up, it was very bright in the cockpit, and fortunately the experienced crew members warned me that it would be necessary to have sunglasses. As we backed away, we just had beautiful views of the space station that we couldn't really see as well when we were right docked with it, but it was just a beautiful sight against the background of the Earth there. And you can see Sergei is beginning the photo documentation. We flew around 1.5 times so that the station could be documented from all sides with different lighting. And those photos will be analyzed by the folks on the ground and used to train future crews as well.
What a fantastic view. What a sense of accomplishment to see an operating International Space Station on orbit.
That shows the empty payload bay. The mission wasn't by any means over yet. We still had work to do. And the next thing we had to do was deploy SAC-A, which was the first successfully launched Argentinian-built satellite. And it has a number of small different experiments and new technologies which are being proven from Argentina. And we understand it's doing very well in accomplishing all of its mission objectives. And it had a slight nutation as it came out of the can, but quickly stabilized.
No crew movie would be complete without some shots of the crew living on orbit. As I said, the middeck is where we live and eat and sleep, and here you can see the crew grabbing a bite to eat. Rick working on the computer there, sending some email home. It's a great morale boost to be able to communicate with your family. Exercise is very important. We have a cycle ergometer. Here I am riding it, and there's Rick using it another way. Computers are a great aid to us. Nancy typing away, sending letters, and Jim with his juggling act. Here's Sergei with a ball of water, showing the unique property that fluids have in a microgravity environment.
There's Jerry running around the middeck.
There wasn't a whole lot of room to get a real lap in.
Nancy said he was just bouncing off the walls.
Food is a very important part of life on orbit as anywhere else. And here you can see me preparing some spaghetti and rehydrating it. All the food during our flight was very delicious. Don't let your kids try this next trick at home. You got to be in 0G to make it work right.
I think this was actually Rick's about 5th package. One of those wasn't enough for a meal for him.
It's true. This was our second hitchhiker satellite we deployed. It's Mighty Sat. It was built at Phillips Lab in Kirtland Air Force Base, New Mexico. It's also doing very well.
Here's my version of the men's warehouse, setting up the suits for deorbit. And then there's always a sad moment when it's time to close the doors. This is triple speed. They actually go a little slower, but we wanted you to see the whole sequence. As the doors come shut, you realize that it's really time to pack your bags to enjoy perhaps one last sunset before getting into those suits and preparing the flight deck for reentry. We've taken a rocket and turned it into an on-orbiting spaceship, and we're taking our spaceship and turning it into a glider to where the commander and the pilot, Bob and Rick, and going to get us home now. Now, as we re-enter the Earth's atmosphere, we have those special tiles that keep us from burning up. Otherwise, we'd be just a brief shooting star. But as it is, we do create a plasma behind us, which you can see here pulsing. And it's so bright that as it flashes and pulses, it flashes inside the cabin. And you can see out the window also that every once in a while there'll be a little shower of sparks. And I always sort of wonder what that was.
Probably little pieces of gap filler between the tiles burning up as it goes by, but again, you wonder. This is a view out the heads-up display on the pilot's side, same as the commander's. We're descending through 28,000 feet, a long-range view of infrared shot, and then again through the heads-up display as we do the pre-flare maneuver, coming down for a touchdown on runway 15 at the Kennedy Space Center. Our touchdown speed's about 195 knots. A beautiful night shot of Endeavour as we come into the brightness of the xenon lights, touching down on speed on centerline. We didn't have a drag chute. Here you can see it through the heads-up display as we rotate the nose down to the runway. But at this gross weight and with the brakes as good as they are, it was not required to have a drag chute for our flight. And we safely brought an Endeavour to a stop. Here's a really pretty view of the support crew coming out to greet us at wheel stop. We also had another welcoming committee. There were some Apollo astronauts at the Space Center for a reunion. There's Jim Lovell and Gene Cernan and Bill Anders, and there's our administrator, Mr. Golden. And there's a really happy crew after an outstanding mission. But this is only the beginning of the International Space Station, and we've got a long way to go. And we're going to take those 2 modules and add a service module for living, and even more modules as the space station continues to grow into a world-class microgravity lab that's in space 24 hours a day, 365 days a year doing science. When it's done, larger than a football field with all its truss structures and solar arrays, and it truly will be the brightest new star on the horizon. And as it goes over the horizon, we know we've got a lot of work in front of us, but we know that NASA and the entire team is up to the challenge.